Right. Hello. This is a short video where I'm going to show you and demonstrate you about the possible situations where two intersecting circle is actually intersect at one point. Means that these two circles, let's say those two example circles, is intersecting at one point. So means that, or another meaning is these two circles is touch at one point, right? So there is two way of circle can touch the they can touch another circle at one point. You see, they can touch the circle externally, alright? Externally, then they will intersect at a point, right? So they will intersect at a point means that they will join. Okay, means such that the situation is the two circles is intersecting at a point, right? This is the point of contact. Alright, point of contact between these two circles, alright, or the intersecting point, but there is only one point, right? So if I'm going to draw between these two circles and I'm going to label this circle, the radius of this circle to be R1, and the circles of the second circle to be R2 with a blue pen, right? So R2, so R1 and R2. So there are two circles. Remember, there are two circles, and these two circles is intersecting at a point. All right, or we say that they are touched externally. All right, the circle touch externally. So we can explain the situation of these two circles by using the concept of radius and the distance apart between the center. All right, the distance between two centers. So the distance between two centers, and I am going to label this as C1, right, center, the first center, and the second center, right, second center of the another circle. So the radius for the first circle will be bigger, right? Assume that one of the radius is bigger than the second circle. So the radius 1 is greater than the length of the radius 2, right? So if these two circles is touched externally, means that they're intersecting at a point, right? So what we can observe, right? The distance between the center of the circle, right? I can say that C1, C2, the distance, or I label it as D, right? The distance between the center of these two circles is actually the sum of the length of the radius of the two circles, right? You see that the center, if they touch, if let's say they touch externally, all right, this is called touch externally, right? Or they intersecting at a point, right? They share a common point. So out of all the circles, they share a common point. So of course, from the center to this center, the distance is the same as the radius 1 plus with radius 2, right? So if you can explain, if you're able to explain that the distance between the two centers is the same as the sum of the two radius, then we can say that the circles, all right, the circles touch. We can say that we can make a conclusion that the circles touch externally, right? Externally. I said, why I'm going to explain this situation? Because by using b square minus 4ac, b square minus 4ac equals to 0, right? Equals to, what is the meaning of equals to 0? Means that these two circles is intersecting at only a point, right? At only one point. This discriminant only can help us to show that these two circles actually has one real roots, okay? Has one intersecting point, but does not really show that these two circles touch externally, alright? Because the two circles can be touched internally. There is another possibility that the two circles touch internally. Alright, let's see. What if the circle is touched internally, right? So let's see what is the what happens if the circle is touched internally, right? Okay. So just now, remember this. So if the circle touch externally, alright, if the two circles touch externally, the radius, the distance, right? They touch externally. The distance between the center of the two circles will be the same as the sum of the two radius. If this is touched externally, but it's different when we say the two circle is touched internally, right? B square minus 4AC discriminant can't really show this situation. So we need the help of this knowledge here. So okay, let's say I label again. This is to be center 1, this is to be center 2. Okay, what happened if these two circle is touched internally, right? We said they touch internally. So okay, there is a center here. So between, I'm going to show you, there is a center. So C1, alright, this is C1. Okay, this is C1, the center for the, so when this circle touch internally, means that they also have one intersecting point, right? Means that on this circle there is one point share with the big circle. Means that for this circle, circle number 2, you have one point which share with the big circle, only one point, right? In this case, we also said that the B square minus 4AC to be equals to 0, right? Same as the first, but from the B square minus 4AC, we just can know that they intersecting at a point, but not really show that these two circles touch internally. So now, how to show the two circles touch internally? Okay, actually inside here, inside this circle, there is a center, right? There is a center. So I'm going to show the center for you. All right, there is a center. All right, this is the center for the. Okay, this is the center for the big circle. Right, big circle. I label this to be C2. Okay, C2. So how to see this situation here? Right? How to see the situation here? So if you see carefully that if you want to show that the two circles touch internally, then you can see that the distance between the two circles, right? The distance between the two circles. Oh, okay. Sorry, this is C1. All right, it's C1. So the distance between the two circles, C1 and C2, can be described as the difference between, okay, this is the big circle, right? This is the big circle. So definitely there is a radius, right? Radius for the big circle. So the radius for the big circle is from the C1 to the contact point here. So this is your R1, right? This is the center of the big circle, all right? Center to the point of contact of the big circle. So the distance between the center, so of course the center for the second circle to this point of contact will be the radius, right? The radius. So can you see that how to relate the distance between the two circles to R1 and R2, right? You can see carefully. You pause the video and you can see carefully. So if you see that the difference between these two, C1, C2, the distance, right, can be described as you take the big radius, the bigger radius minus the smaller radius, right? So you see that C1, C2 means that the distance between the two center can be described as the difference between the radius of the first circle minus with the radius of the second circle. If you're able to prove that if you're able to prove that the distance between the two center is the same as the radius of the first circle minus the radius of the second circle, or the biggest radius minus the smaller radius, then you already show that the circle touch internally, right? You see that they touch at this point, right? And this big circle has the center, right? Center. So from the center to this point of contact is radius 1, and from this circle, center of the circle of the second circle to this point of contact is R2, right? So of course there is a distance between these two centers, right? So this distance will be the same as the taking R1 minus R2. Alright? So now can you see the difference between the two these two situations here? Alright? So for the first one, just now for the first one, where they touch externally, okay, where the circle touch externally, then you can see that clearly this one, right? So the distance between the two center, right? The distance between the two center is the same as R1 plus with R2 if they touch externally. So, and the second, then the D will be R1 plus R2. So now, if the two circles touch internally, alright, internally, so I'm going to draw the center here. So it's okay. So they intersect at that point, right? They intersect at a point. So, and this is the center of the big circles, and this is the center for the second circle. So the distance from the center of the big circle to the point of intersection here will be R1, right? Definitely will be R1, and this will be R2, right? So the distance between the two center will be R1 minus R2. D equals to R1 minus R2 if the circle touch internally. Just now, the other situation is the circle touch externally, right? If the D equals to R1 plus R2. Alright, that's all for the circle that belong to the case of B square minus 4AC equals to 0. If you want to do further investigation. Right, that's all for this video.